Hi students, good morning. Those who are seeing this video, please subscribe for me. Today I am going to teach you single displacement reaction. It is a reaction between an element and a compound. So one element and a compound. When they react, one of the elements of the compound, reactant is replaced by the element. So one element, one compound. In this compound, one of the element will be replaced by that element. Reactant element to form a new compound and an element, and then also one element, because here two elements will be here, one of the element will be replaced. See here B is replaced, so this is the here also we will get one compound and one element only in the product side. So the general schematic representation of a single displacement reaction is given as A plus BC. BC is a compound, A is an element, gives, and here in BC, C element, B element is replaced and C element is joined with A and form a compound, and B is, so this is the product. So a displacement reaction B from the compound BC, and hence a single displacement reaction occurs, because here only one element only displaced. So this is a single displacement reaction. If zinc metal is placed in hydrochloric acid, hydrogen gas is evolved. Here the hydrogen is displaced by the zinc metal and zinc chloride is formed. So zinc plus HCl, hydrochloric acid, that is an aqueous solution, gives zinc chloride. So here also zinc, the valency is 2 and chlorine valency is 1. Now we crisscross it, we'll get ZnCl2. So ZnCl2 aqueous, because it's also solution, plus H2, it is displaces a hydrogen gas. From HCl, hydrogen gas is displaced by the zinc and forms zinc chloride and hydrogen gas. And now we have to see the chlorine. Here the chlorine content is 2. So in reactant also we should write 2. So here Zn a solid plus 2 HCl aqueous gives ZnCl2 aqueous plus H2 gas. So here H2 is here, here also 2H2. So it is a what is the balanced equation. And then iron. Iron is a solid and copper sulfate is an aqueous. So now iron displaces as a copper from copper sulfate and it is form a iron sulfate. So Fe sulfur plus CuSO4, the copper sulfate. So here Cu is 2 valency, sulfate is also having 2 valency. So 2 cancel. So we have to find the ratio, no? So 2 cancel. So CuSO4. So and gives FeSO4, ferrous sulfate. In ferrous, the valency is 2. For sulfate, I already told sulfate is valency 2. So now this is also cancelled. Now we have FeSO4, ferrous sulfate, and copper is displaced. So here in the iron is in solid form, copper sulfate is in aqueous solution, and FeSO4 is an aqueous solution, and copper is a solid. So if an iron nail is placed in an aqueous solution of copper 2 sulfate, iron nail, copper sulfate, so copper sulfate solution, the iron displaces a copper. The iron displaces a copper from copper sulfate solution and it is form a iron sulfate. Copper deposit over them. So because of iron is gives out copper, so the copper will be deposited on the iron nail, over the iron nail. So it is easy to propose so many reactions of this kind with a different combination reaction. So will they all occur in practical? No. This is the most easily demonstrated with halogens. Sodium chloride, that is our common salt. Common salt and fluorine gas. Because I told always fluorine we should write in diatomic state, and it is form a sodium fluoride. So NaF. So sodium is also having 1 valency. Fluorine is also having 1 valency, cancel. So we'll get sodium fluoride and chlorine gas. Chlorine gas, diatomic stage. And you see here the chlorine is 2, so we have to write 2 here. So it become chlorine also become 2. Now it's Na is 2, so now we should write Na here, because here F2 is here, 2F2. So it is a balanced equation. And NaF aqueous plus Cl2 gives NaCl. Again NaF aqueous we are adding Cl2. It forms a sodium chloride aqueous and F2 gas. Same thing is happened. So the first reaction involves the displacement of chlorine from NaCl. In NaCl, chlorine is displaced. In second reaction, fluorine is displaces and chlorine is water. It is combined with the sodium form sodium chloride. So this the second reaction will not occur because this is it is impossible. Why? Means because fluorine is more active than chlorine, because fluorine is more active than chlorine, so chlorine can't able to displace fluorine. So we should know thoroughly sodium chloride and iron. Fluorine gives sodium fluoride and chloride, this only occurs, but this is not occurs because fluorine is more reactive than chlorine. So this occupies the upper position of the period. Fluorine is having the upper position of the periodic table. So in displacement reaction, the activity of the elements and the relative position in the periodic table are the key factors, because we should see this will happen, this may not happen. So here the Cl can do it, but fluorine can displaces chlorine, but chlorine can't displaces fluorine because fluorine is only the more reactive in nature. And so we should see the relative position in the periodic table or the key factors of determine the feasibility of the reaction. More active elements readily displaces less more active elements, because fluorine is more active, so it can displace the less active element chlorine of the aqueous solution. So the activity of the some element is given below. See here, it is given to remember. We should see, please send lions, cat, monkeys and zebras into lovely hot countries, signed General Penguin. So potassium, P means potassium, K, and so Na, send, S, NSS, sodium, and lion, lithium, cat, calcium, monkey, M is the first letter, magnesium, and aluminium, A is a capital letter, zebra is an N, zinc, and iron, Fe, lovely, lead, PB, hot. So you should memorize this one. You can able to write the activity series. So potassium only having the more active and less active is given here. So if you see the hydrogen, and C is a copper, S is a silver, G is a gold, P is a platinum. So platinum is a less reactive element, and potassium is more reactive, and sodium is then less reactive than potassium. Like this it will come. So you should remember this, and you can able to know the reaction properly. So which can displaces which. So more reactive elements only can replaces the other less reactive elements, students. So please thorough it, and you should read it, and you send me the anything I want to teach you, send me in the send me, and then subscribe for me. Thank you, students.